Good morning. Now I am going to upload the lectures which relates with your term work. Now if you remember, you have already completed your term work and you are going to face oral, that is Monday onwards. Now what we have in term work, so we have 4 sheets which are related with your drawings, or we can say plates. So that are our 4 sheets. And now in these videos, we are going to talk about these 4 sheets. Now after that, you have 2 sheets which are related with trusses. So you should know what you have in your term work while you are going for orals. 2 sheets, these are for your trusses. And in this, you are with 1 sheet, that is graphical method. And second sheet, we have detailing of truss. And then we have remaining 2 sheets. So 4 plus 2, 6. We have 7th sheet, that is on gantry girder. And 8th sheet, we have on plate girder. Welded plate girder. So here actually we have 1 to 4. This is 5 and 6. And then 7 and 8. Now we will start in first. So whatever we can cover from 1 to 4. So we will go with small videos, not large one. So now I will go with first sheet. So now you can see we have these 4 sheets. And now in this we are going to talk about drawing sheet number 1. Now I will go to drawing sheet number 1. So we have in this drawing sheet, we are with 4 sketches, or we can say we have divided this into 4 parts. In first part, we have hot rolled steel section. Now in this, you have to go to steel table. And in this, you can go through all rolled sections. And we have this rolled section nomenclature. If you will see, we have these 2 are common. That is Indian standard. And then we have different, we will see in next slide. MB, we have WB, we have HB, we have LB, we have like this. If I will talk about channels, then I have ISMC, I have LC, I have JC. So like we have, if I will go angle, I have ISA, and that is for both, that is equal and unequal. Second, we have section dimension for classification. So we are going to use in this table 2, which is on page 18, and figure 2, which is on page 19. So we are going to see that also over here. Then bolted connections, so which are different types of this bolted connection, that we are going to see over here. And then welded also we have. What are the different types of welded connection will be seen over here. So now we will go with first hot rolled steel section. So we are with this. So mainly we are going to use this Indian standard wide beams. So ISWB. Now these beams are generally used in gantry girders. Preferred in gantry girders. Now, Indian standard medium beam and Indian standard light beam, these are generally preferred for, these light beams are preferred for low load, or we can say large load with small span. Small spans. Then MB generally we are using with larger load, larger span. larger load and larger span compared with ISLB. Because for a heavy or very large load and very large span, when these are not satisfying, we are going for built-up section or we are going for welded plate girder. Now you have to see this in this. We have largest one section, that is ISWB 600. Now sometimes they may ask you what is ZP for this, and this something I don't remember exact value, but we have something 6400 centimeter cube. Please check this value and keep in mind what is maximum available value of ZP. Check it. Maximum available value of ZP. And that value is of ISWB 600. So these are Indian standard beams. Now we have junior beam for light loads, we can say. ISHB we have not mentioned here. But ISHB we are using for column sections only. Now why we are going for likewise? Now why ISWB we are using for gantry girders? Because we have wide flange of this. And if flange is wide, it becomes easy for us to have channels on it. So we can have flange. If we have wide flange, then we can have channel on this. And in that case, this distance will be less. So cantilever part will be less. And you are going to get this less cantilever part, and welding it becomes easy for us. So now ISWB these are preferred while we are going for gantry girders. Now we have ISHB, we are going for columns. In these columns we are going, a reason we have that is these are heavy. Name itself indicate we have flange width is larger. And we have ZP also in that case larger one. And therefore we will prefer this one. Now we have second Indian standard medium channel. ISMC, now I have already mentioned this. Then we have ISJC. Names we have over here. You can go, we have more over there. ISSC. So different you can see from steel table. We have mentioned some of this. And then you have to see it. Now this we should know this R1, that is root of radius at the junction between web and flange, and this is for flange only when we are going to be from flange junction to the outside. So this is R2 and R1. So you can draw this and you can show in the examination. Similarly, R1 again here we have, that is at junction between web and flange, and this is when it is going outside, that is of channel section. So these are the different beam section, channel section. Now this I will explain in detail why we will go ISWB. Then these actually we are not using IS Indian standard normal T, then Indian standard deep T, Indian standard light T, but they may ask you what are the different T sections available. So N normal, then we have D deep T, that is depth is more, then light, L for light, and J for medium, or I can say better this as junior. Then also it's okay, because generally J they are using for junior and M we are using for medium. Indian standard equal angle section, and you can see R1, R2, root of radius you should know where we have, because sometimes he may ask So R1 again we have at the junction, and R2 going when you are going outside. Now you can see here we have this A and B. So in this case, we have A equal to B. So this A should be equal to B. And Indian standard unequal, both are denoted by same name, same nomenclature. Students confused with this. Here students are going to say ISA, Indian standard, or EA, and here they are going to say ISUA. That is not there. So we have same nomenclature for this. Here A is not equal to B. So we should know these different. You can go to IS code, you have to check. If some of them are not mentioned here, you try to check it, because sometimes your external examiner may ask, you have written which are missing in this, and in that case you should know which are missing, and for that one you have to check your steel table. Now second, we have this dimension classification. Now for this we have, this will be beam section. This is given on page 19. You should know this. Page 19, IS 800 2007, and this is figure 2. This is for how, what are the classification? He may ask you. So we have 4. Plastic, section is plastic, then section is compact, section is semi-compact, and then section we have slender. Now he may ask on which basis you have decided this section. So this section we have decided on your stress curve. Now, if you remember plastic analysis in structural analysis 1, there we have all fibers we are with value of sigma y, whole section. If I will draw this section, and then when I have this all, so I will plot here only, so it becomes easy for you to understand this. So we have these all fibers of this section, these are in sigma y value. So I will plot over here, and then if this happens, then we have value that is being larger than, so sigma y, and then these are going to form a couple which will give us moment of resistance. So this section is my plastic section. Then what is compact? Part of the fibers or partly fibers, these are going to be sigma y, and partly we are going to be less than sigma y. So this portion you have value that is sigma y, and then it is reducing, becoming 0 over here. This is compact. What is semi-compact? So we have only end fibers, these are value sigma y. Then others are reducing, becoming 0 over here. And what are cylinder? So in cylinder, you may have local failure, or your end fibers also not going to be with value sigma less than sigma y. Sigma, we are not going to prefer this, because in this we are not going to get maximum value. Or we can say, if you remember, you will go to section 7, and they are going to say your value that is going to be AE less than or equal to AG. And that depends on your this section. So if that goes beyond this semi-compact, then you are not going to consider that portion. So slender we are not preferring in your design, that is of steel structures. So you should know therefore which section we are going to be plastic, which section we are going to be compact, semi-compact, and then we have that plastic. And these sections we are going to be decided over here. On this basis, IS code has given some values, and that are tabulated in your table 2. So you have to refer table 2, and from table 2 you are in position to answer the questions for plastic, compact, semi-compact. For these three, plastic, compact, semi-compact, we can use this section, but for slender we have to revise this section. Then same from table 2 you have to find all these values, and in this case you have to keep in mind, for this we have this as B upon TF, and B you can see this BF by 2 upon TF. So that little bit you have to keep in mind, because sometimes they may give you, suppose you have flange width that is 140, and then you have this value suppose given as 280 something, and ask what is value of B by TF. You should be very careful. You have to go for 140 by 2 divided by 280, and then you have to answer it. See, same for all, you have to go through figure 2. Now here you have to see this. If this, what is difference, they may ask. That is in welded section and in rolled section. In rolled section it is BF by 2, but in case of welded section, if I have this as BF, then we have to keep in mind it is BF minus TW and then divided by 2 upon TF, because you can see it is mentioned only outstanding part of the welded section, whereas in rolled section it is taken this value. This you can see this. So good detail in this. Same B, D, we do not have that much part. We have same. Then T also we have overall depth, and B that is again from center, and angle section that is B by D. That we know already, we have solved many problems. Bolted connection, they may ask you which connections you have used. So mainly we have in our syllabus, we have this chain bolting, you can say, or we can have this staggered bolting. Now you should be in position to answer this. What is pitch? It is the distance between the two bolts in the direction of stress or in the direction of force. Better in IS code it is given in the direction of stress, so mention in the direction of stress. That is pitch. What is end distance? So this is again distance between the end bolts to the end of the plate, that we are going to say end distance. Again it is in the direction of stress. So pitch and end distance, these are along the same direction, and gauge distance again perpendicular, center to center distance between two bolts, but perpendicular to the direction of stress. So edge distance, that is distance between center of bolts to the edge of the plate. So this gauge and edge distance are perpendicular to the stress in the same direction, and pitch and end are in the same direction. Now in staggered we can see this, your cross-sectional area is going to change. You have to go with different sections and then you have to find minimum. Whereas in this we are going to be directly B minus NDH into T. But here we have B minus NDH plus summation S square upon 4G, once check the formula, into T. That is S, or you can say P. So that is pitch upon 4G. This is summation, and that is I to N, or you can say whatever you want. And in this, he may ask you to find the area, so net area, and in that case he may give some values. So you have to go to, I have already uploaded that questions which are related with your DSS theory. So if you will go to playlist, and in this playlist I have uploaded oral questions on DSS, oral questions DSS, and there you can go over there and then you can read it, you will understand it. Now double cover butt joint or lap joint. So difference you can see this. We have this as lap between the plate. Means two plates we have on each other, lapping each other, and then we have this connection. Whereas this single cover butt joint or double cover butt joint, you do not have lapping of these two plates which we are going to connect it, and these cover plates we are going to use, whereas here we are not going to use any cover plates. So that is the main difference. Lap, you have this lap length depending upon your number of bolts, whereas here we do not have any lap length. You can see these two plates we have separate over here, and some gap is there, that is 2 to 5 mm over there, and this is known as double cover butt joint, because here we are using cover plates to connect the plate. If he is going to ask what is difference between single cover, so in this you have cover plate only on one side, so we have cover plate on this side only. So likewise, you have to go for this. And then we have welded connection. Now in this, we have not used all these welds. You can say we have used only two. That is, mainly we can say we have used, that is fillet weld. And that fillet weld we will have detail if you remember in your theory part. So there you can go over there, and that you can answer for him, that these we have not used. We have drawn this single V. Now you can have double V, single B well, double B well. So just C U, double U, single J. So name according to their name letters. We have this J. You can see we have like this. Then B well, you have to just keep in mind. V you can have like this, double V we can have like this. So likewise U you can have like this. So that just you keep in mind, and if asked then you can answer. So for first we will stop here only. So that will be related with your first sheet, and then in next video we will go with second sheet. So we will stop here now. Thank you.